Well, welcome back. Happy New Year. Happy new chapter. Happy new everything. Here we go. Ready to start chapter 6 today. We will cover three, one, two, three, count them, solving methods for finding solutions to what we call systems of equations. We'll talk about what they are here in just a minute, but today's solving method we are going to use what we learned in Chapter 5 with graphing and figure out how to solve systems of equations using the graphing method. Later on this unit, we will also look at solving by what we call substitution, and then also the other final method called elimination. So, what is a system, you ask? A system of linear equations is a set. And in our little world of Algebra 1, it's going to be a set of two equations that contain the same variables. Today for graphing, you're going to see the two variables, your friend and mine, x and y. For instance, here is a system of equations. Notice there are two equations, and they have the same variables. X and y terms are in both equations. They don't have to be the same like 2x, 2x. Just that there is an x term here and an x term in the second equation. Y in the first, y in the second, and we've got our little equal sign there. So that is what a system looks like. So I have two examples here, and in our first set of examples, we are actually not going to solve these systems. We are going to determine whether or not a given ordered pair, x comma y, is a solution for the given system. So what I'm looking at here in example 1 is the point -4, -1, x is -4, y -1. Is that a solution to the entire system of equations? So what we need to ask is not does it just work for one or the other equations, but does it work for both? So if x equals -4 and y equals -1, makes the first and second equations true, then I can say yes, it is a solution to the overall system. So let's take a look with equation 1. For x, I'm going to plug in -4, and for y, I'm going to plug in -1. So I'm going to take -5 times -4, and then add y, which is -1, and see if that is equal to +19. So -5 times -4 is +20, plus -1, is that 19? Yes, 19 does equal 19. So we're good for the first equation. Now remember, I can't say it's good for the system yet until I check equation 2. It has to be a yes and yes for both. So I'll draw my little separation line here. So equation 2, x, which is -4, minus 7 times y, which is -1. Does that equal 3? So -4, and then -7 times -1 becomes +7. Does that equal 3? -4 plus 7, 7 minus 4, 3, does equal 3. So since we have true statements here for both equation 1 and equation 2, for x equals -4, y equals -1, I would say yes, this ordered pair is a solution to that system. Example 2. We are going to check now if I plug in 6 for x and 3 for y into the given system. -2x plus y equals -11, and -x minus 9y is -15. If I plug in these two values, 6 for x, 3 for y, 6, 3, do they make both equations true? Let's check it out. First equation, -2 times x is 6 plus y 3. Does that equal -11? Well, -2 times 6 is -12. negative 12 plus 3. Let's see, that's negative 9. And we want this to be negative 11. Ooh. So does negative 9 equal negative 11? It does not. Negative 9 does not equal negative 11. So since x is 6, y is 3, does not work for the first equation, there's no way it can work for both. So I can right away, without even checking the second equation, say no, x is 6, y is 3 does not work for the second system. That's checking. We'll be right back to show you how to solve the systems by graphing. How do we find the right ordered pair? It'll be great. All right, part 2 now is where we are going to look to solve these systems by graphing. So we are trying to find the ordered pair x comma y that is a solution to both the first and the second equation. So to do that, we need to be able to graph both lines on the same coordinate plane. We are then going to find that solution by finding or identifying where the two lines cross or intersect. So, big fancy reading here. To solve a linear system by graphing, we need to find an xy ordered pair that is a solution to both equations. So if you think about, just visualizing, you've got line 1 is graphed somewhere. It's got all these points on it that are solutions to that line. Line 2, my blue line, has all these points that are solutions to it. So the one point they have in common is right here, this point of intersection. So that is our key point. When we solve by graphing, remember chapter 5, to graph an equation, it needs to be written in y equals mx plus b slope-intercept form. So with these equations, they're not always going to be in y equals mx plus b form. So a good little refresher to get the equations with y by itself. So equation 1, x plus y equals negative 2. X plus y equals negative 2. To get this y alone, I am going to have to move the x from the left side to the right side. So I'll minus x from both sides and have y equals negative x minus 2. So with that line, I need to start with b, the y-intercept, is negative 2. And then m, the slope, the rise over run, it's negative 1 over 1. So y equals m, negative 1 over 1x, plus b is negative 2. So when I graph that line, I'm going to begin at negative 2, so down 1, down 2, starting on b. My rise over run, the slope, is negative 1 over 1, so I'll go down 1, 1 to the right, down 1, 1 to the right, or I can also go up 1, 1 to the left, up 1, 1 to the left. So there is my first line. I am now going to graph the second line, 2x minus 3y equals negative 9. So if I write that equation here, 2x minus 3y equals negative 9. To get the y by itself, I'll subtract 2x from both sides. Negative 3y equals negative 2x minus 9. And then last thing to get y alone right now is it's being multiplied by negative 3. So to undo multiplying, I'll divide all terms, both sides, by negative 3. y equals negative divided by negative is a positive 2 over 3x plus 3. So equation 2, I'll use black. I'll stick with the blue, no worries. B, the y-intercept, is 3, and then m, the slope, the rise over the run, up to 3 to the right. So B, the y-intercept, is 3, up 1, up 2, up 3, and then I'm going to rise 2, and then run 3 to the right. Or I can go down 2, 1, 2, 3 to the left. So my solution is going to be where these 2 points cross. Here it is. 1, 2, 3 to the left, up 1. So my claim is that the solution to this system is x is negative 3, y is 1. How do you know if you're right? Well, you can always check it. Let's plug in negative 3 for x and 1 for y. Is negative 3 plus 1 equal to negative 2? Good! And then equation 2. 2 times negative 3 is negative 6 minus 3 times 1. Is that negative 9? Negative 6 minus 3 does equal negative 9. Good. So negative 3, 1 would be my solution to this system. Why? Because it is the x and y value that works for both the first and the second equation. And how did I find that? Well, I graphed my 2 lines and found the point at which the 2 lines crossed or intersected. That's it. Let's try one more, so we're all healthy, wealthy, and wise. So I've got my second equation, 6x minus 3y equals negative 15. And equation 2 in this system, 2x plus y equals negative 3. First thing I need to do in both equations is to get y by itself. Y equals mx plus b. So the first equation, I've got 6x minus 3y equals negative 15. My goal is to get the y by itself right here. So I'll move the positive 6x over by subtracting. Negative 3y equals negative 6x minus 15. And then to undo multiplying by negative 3, I'll divide both sides by negative 3. And I'll have y equals negative 6 over negative 3 is positive 2 over 1 x. Negative divided by negative plus 5. So 2 over 1x plus 5. When I graph that, I will begin at 5 and then rise 2, run 1. So up 1, 2, 3, 4, 5, and then go up 2, 1 to the right. Or I can go down 2, 1 to the left, down 2, 1 to the left. So connecting my dots, there is the first line. Line 2 is a little nicer to get in y equals mx plus b form. Notice here 2x plus y equals negative 3. Y is being added with negative or with 2x. So I'll subtract 2x from both sides, and that will get y alone. Y equals negative 2 over 1x minus 3. So my y-intercept, b, is negative 3. Down 1, down 2, down 3. And then m, the slope, the rise over run, is down 2, 1 to the right. Down 2, 1 to the right. Or I can go up 2, 1 to the left. Up 2, 1 to the left. And bingo, there it is. My 2 lines intersect right there. And that point is 1, 2 to the left, up 1. So negative 2, 1 would be my xy ordered pair solution. Check it if you'd like. 6 times negative 2, negative 12, minus 3 times 1, minus 3, equals negative 15. Good! And then with equation 2, 2 times negative 2, negative 4, plus y is 1. Does that equal negative 3? Good! It sure does. All right. So that's how we get our solutions, our ordered pair that is both a solution for the first and second systems here. Graph your first line, graph your second, find that point where they cross, and you are a East Tonka champion. Fly on, we will continue with solving by substitution here in our next section. Do not hesitate to reach out if you have any questions or need clarifications. Thanks for your time.